Okay, I guess we can begin. Hi, everyone. My name is Alina. I'm very happy to see you here. And before I say anything else, I need to thank my friend Andres, who brought me here and explained to me how time design zones work, because I messed it up. Thank you, Andres. And in this session, we will talk about GraalVM and the things you need to know about GraalVM if you are a Java developer. Now, this is my first time at this conference, and I would like to make this talk useful for you, so I would like to adjust it to make more sense for you. So can you please raise your hand if you're a Java developer? OK, everyone almost. And can you raise it again if you have tried building something with GraalVM already? OK, some people, 1/3 maybe. Cool. OK, I think we are all set. So a few words about me. This is my name, and this is my handle on social media. If you want to ask any kind of follow-up question, if you want to ask for demos, slide, etc., you can just reach out to me on social media. And I work as a developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, which is an R&D unit at Oracle. So we are very proud of working on this team, because Oracle Labs originates back from the Sun Microsystems times. We used to be Sun Labs, where we are doing a lot of research, and now we are doing the same thing at Oracle, developing those new bleeding-edge kind of technologies. I love open source and I love communities. That's why I like coming to conferences like this one. And I like equally programming in natural languages. I can say maybe 5, 7 words in Portuguese, but I'm very open to learning more. So if you want, you can try teaching me more during the lunch break. And with that, let's talk about GraalVM. Now, a very quick intro, because GraalVM is many things, and sometimes it's confusing. Some people call it AUT compiler, some call it a polyglot VM. But in the end, GraalVM is a JDK, just like any other JDK of your choice. You might be using OpenJDK, you might be using Oracle JDK, whatever vendor you prefer. And GraalVM is a JDK just like that. And we don't really remove anything from the JDK, we just add more things on top of it. So one thing that we added on top is this ahead-of-time compilation of Java applications, something that is very new to the Java ecosystem, where you can compile the application ahead of time and turn it into a native executable that will act similarly to other native programs. Now, another big part that we have added to the JDK is Truffle, our language implementation framework. So in addition to Java, you might have heard that you can execute other languages on GraalVM. So you can execute, for example, JavaScript, Python, WebAssembly. And what is even cooler, they are all implemented in Java. And lately, we have made a change where you can bring those languages into your Java application just as a Maven dependency. So let's say you have your Java application, and maybe there is some cool data science, ML library somewhere out there in Python. So what you can do, you can bring our Python implementation into your project and start using that library in Python from your Java application. But in this talk, we will focus specifically on this native image ahead-of-time capability of GraalVM. So the main thing to remember about GraalVM is that it is a JDK. And when it comes to Java programs, you get this choice that you can use it either as a Java runtime to run your programs as you would on any other Java runtime, or you can compile the applications ahead of time into a native executable. So with GraalVM, unlike many other JDKs, you get this choice to make. Do I want to run my program on the JDK, just with a better, different, just-in-time compiler, or do I want to go all in native image and have a native executable? And this slide is also my answer to a question that I often get at conferences. People like asking me this, what they think is a tricky question: when should I not use GraalVM? And my answer is always use GraalVM. But decide for yourself what is a better use case for you. So do you want to stay in the JVM world, where the migration is very easy, and you can get maybe 10, 15% performance improvement by switching to GraalVM? Or do you want to go for faster startup and lower resources usage, and then you should use native image? But whatever you decide, GraalVM can give you a chance to do either. Now, I also like showing this slide because I mentioned that we are a research org, so we've been working on GraalVM for over 10 years now. And the reason I like this slide is, A, because I think it's a beautiful slide design, so I'm just happy about what our team has accomplished there. But also, there are some important milestones there over the years that we have been working on this project. So one milestone is that we started working on GraalVM pretty much in 2011, so 13 years from now. But then in 2019, we finally went with our first production-grade builds. So since 2019, you could have been using GraalVM in your production environment. It went out of this research stage. And what's more interesting, the team working on the Micronaut framework have recognized GraalVM even before then. So even before we went GA and were recommended for production, the Micronaut team back in 2018 already saw this potential, and they added integration with GraalVM because they appreciated those benefits of native image. Then one more point is that Oracle Cloud, our own cloud, is also running on GraalVM starting from 2019 and until now. They are moving more and more services to GraalVM because they see those performance benefits. And one point that is very dear to my heart is that since 2020, Alibaba have been deploying applications based on GraalVM native image in production. And the reason why this is so important to me is because native image might seem like this revolutionary, maybe slightly scary technology, but as you can see, some people, such as Alibaba at a huge scale, have been using native image in production for over 4 years now, and they were very happy with the stability and the gains that they got. And the last but not least, in 2022, Spring Boot also added support for native image out of the box. So now when you are starting a new Spring project, you can add native image out of the box and compile your applications with it. So what is this native image, and how is it even possible to take something as dynamic as a Java application and compile it into a native executable? So this happens ahead of time as you are building your application. And the main point here is that it needs to happen under a closed world assumption. So everything there is to know about your application needs to be known ahead of time when you are building your application. And you need to be able to instruct native image exactly what needs to happen in your application and what needs to be visible to your application for your application build and runtime to succeed. And the way this works when you run our native image build and you give it your application is that native image will look at your application starting from its main entry point, and from there it will try to find all the reachable code. So all the code that is actually involved in what your application is supposed to be doing, to only include that code into that produced native executable. And this applies to the code that you yourself wrote, so your user code, but just as well to the JDK classes and even your dependencies. So we will analyze your project as a whole and then only include the things that you actually need in this final produced native executable. Now, this is one part of the story, and because of this, native image is sometimes called an IoT compiler, but this is not the full story. There is another important aspect of it, and that is that we will also look at your heap as we are building your application, and we will take a snapshot of it, of the classes that are safe to initialize at build time. And then we will build a native executable that also includes that snapshot of that heap that makes you start faster at runtime because that heap is already available in the native executable. So two key concepts, ahead of time compilation and under closed world assumption. And as an output here, you will get a native executable that will be specific to the platform. This is also important. So if I'm building, let's say, on my Apple Silicon MacBook, it will be suited for my Apple Silicon MacBook. So it is specific to the target platform on which you are building. Now, with all the talking, let's finally see it in action, and let's look at a couple of demos. So the first thing I want to show you here is this Spring AI application. Obviously, you cannot come to a conference these days not showing an AI application. Everyone does this, right? Otherwise, you wouldn't get accepted. So let's run it. First of all, let's check my Java version. And here I am on Oracle GraalVM for JDK 23. Now, if you're wondering how often you get GraalVM builds, you get them as often as Java builds. So every time there is a new Java release, you also get a GraalVM release on the same day. So if you want to always get the latest Java release, I would suggest that you just get GraalVM, and that will give you the latest of Java features and the latest of GraalVM features in one JDK download. So here we are, and it's a Spring application, so let's run it. Maven Spring Boot run. And this is running on a cloud instance, means it's isolated from all my screen sharing and slides, and also the instance is fairly beefy, so you cannot say that I'm running this on a very resource-constrained environment. JVM really has a chance to shine here. So the application started, and it's running on the port 8080, and it started in something like 1.7 seconds. So let's see what it actually does. And I think I might need to remap my ports. Okay, let's see. Okay, So this is our travel recommendation app. Let's say we want to travel to some country and we are not exactly sure what to do. So this is our application that will leverage Spring AI and the OpenAI API behind it. And also you can tell that this is a front-end application written by a back-end person. It might not look like much, but trust me, it looks much better than it did in the first iteration. So that's an accomplishment, I would say. So let's say we want to travel to Portugal, and maybe we, I don't know, want to do hiking, because people keep telling me that hiking is fun. And let's say we are in the adventurous mood. So let's see if we can retrieve some recommendations from here. Okay, so it says we should go to the Peneda Gerês, is it? National Park, wild horses, deer, and the elusive Iberian wolf. Okay, you can tell me afterwards if you think this is a good recommendation or not. But clearly, our application is running and functional. But it did take some time to start, right? So it started in 1.7 seconds. I think we can improve that. So I already have compiled as a backup my native application. But, you know, there is fun in that. Let's recompile live. So how do I compile it to native? For that, I would need to do maven p native compile. And this will start my native compilation build. Sorry? Oh, what happened? Was it me? Yes, it was me. Good. Thanks. Now, my application now will compile to native image. As it compiles, let's explore what's actually inside the app. So this is our project, and it's not even that large. So I have my main class. I have my controller that handles the interaction with the user. I have my service that goes and talks to the OpenAI API. And then in resources, I have my little front end. So the application is not that big, but we will see in a bit that the compilation will take a while. And why is it so? So even for this trivial application that has maybe 3 classes that I have wrote myself, we see that we have here 22 reachable types. So those are the types that native image deemed necessary for the application to run. And then in terms of how many methods it have found in my application, over 100,000 methods are actually needed for my application to run, again, for this fairly trivial application. So where is this complexity coming from? We know that the Java platform is very powerful. It gives us great features for productivity, all the necessary tooling for our work to be done and for performance. But it also means there is some complexity in our project under the hood, specifically if we are pulling in SIM framework and dependencies and all the things that I need to build applications for production. So even this fairly small application, if you look under the hood, it has a lot of complexity inside. But as I was talking, in the meantime, our application has been built in just 1 minute and 27 seconds. This is not your Java C compilation, but still, I would say this is fairly quick for a full-blown Spring Web application. Now, if I'm not happy with this compilation times, there is a little optimization that I can do. And what I can do, I can go to my POM.xml and add one flag to the native image plugin that is called -ob. And this flag will make my build faster by not applying all the performance optimizations. So if I'm still developing my application and I don't care about peak throughput yet, I can add that flag and tell, hey, I'm not deploying yet. I just want to make sure that things work. Please give me faster builds, and I will optimize for production later on. So if I had that flag on, it would have been maybe like 1 minute, which I would say is a very good time, because what native image offers you, a trade-off, where you can move all this work from runtime, where a JVM would normally do it, to build time. So we give you an opportunity to say, hey, I want to move all this work to build time, do it once, and not spread it across runtime as the JVM would do it. And we think this makes sense because more applications are started more often than they are built. So it kind of makes sense to spend all this time and resources once when you build your application. And then every single time you need to start it, it will start much faster. But let's see how faster exactly. So target travel app. So if you remember previously, our application started in something like 1.5 seconds. Now it's down to just 52 milliseconds. But let's see that it's still working and doing what it's supposed to be doing. So let's come back here. We see the same UI. Let's just make sure that it's working. So again, let's go to Portugal. And I've heard that it's a nice destination for surfing. So maybe let's try surfing. and maybe we feel risky now. So let's see if we can get some recommendations. Known for its gigantic and challenging waves, attract surfers from all around the world. Okay, sounds good, and we can see that our application is still functional. So this is how you will make your application a native executable. Now, let's talk more about why you would do it and what are the benefits. So one clear benefit of native image is fast startup times. We have seen that our application went down from 1.5 seconds to just 52 milliseconds. And in general, it will be always the case with native image, no matter how big or small your application is, no matter your dependencies, there will always be orders of magnitude faster on native image. Now, you might tell me, OK, but let's say I have a Java application that I run in production. I deploy it once, and then it runs for hours and days and maybe weeks. And I don't care about startup that much because I deployed it, and then it runs for a very long period of time. I agree with you that often it's the case. That's why I think one, maybe even more important benefit of native image is lower resources usage. So when you run an application on the JVM, you need the actual JVM at runtime. And also, the JVM does a lot of work as you're running your application. So it needs to load your classes, profile, interpret, compile, GC, etc. And for all of that, you need to keep around CPU and memory to do those kind of overhead infrastructure operations as your application runs. Now, because native image offers you a trade-off where you move all of that to build time, you don't need to keep around that much memory and waste that much memory as you run your application. We always recommend that you measure for yourself and for your own application, but on average, you can expect, I would say, 3x, 5x less memory usage with native image as opposed to the JVM. So not 3-5%, but 3x, 5x. I think it's a good deal. And another interesting aspect of native image and a benefit is that its performance is very predictable over time. So if you were to imagine the line showing a picture output of your application on the JVM versus native image, on the JVM it will be like lower in the beginning, then warming up, and then there could be spikes and downfalls as your application runs because there is a lot of dynamism in how Java executes your application. Now with native image, it's all optimized and compiled ahead of time, so the performance will be very stable, and also application will be fully warmed up and available from the first milliseconds. Now, there is another aspect of native image, and that is that it has a very different security profile from running your applications on the JVM. In particular, things like reflection and serialization require a specific allowed list from your side, so you always have more control and awareness over what is happening in your application. And it also eliminates the code that you are not using, and this way it's reducing the attack surface of your application. Also, if you want to have smaller applications, maybe smaller container images, again, by stripping everything that you don't need and stripping away the JVM runtime, native image gives you those smaller container images. And lastly, if you are starting a new application now in 2024, there is really no reason for you not to use GraalVM because all the major frameworks and cloud vendors have added support, and it's very easy to use native image and GraalVM right now. So specifically for new projects, I do think that you need to evaluate GraalVM. Now, let's talk about frameworks and libraries. And if you want indeed to use native image in production, obviously you will need to use libraries. So if you have tried native image in the past, maybe like 4 or 5 years ago, you could have faced some issues with using the library, such as you added a library or you have tried moving an existing project and it wouldn't work. I'm wondering, have anyone faced such issue with using libraries and native image? OK, one person. This is good. Now, let's talk about how you can solve such issues and where they could be coming from. So the source of those challenges sometimes is that, as I mentioned, native image executes your application, builds your application ahead of time. And this means that those more dynamic Java features, such as reflection, serialization, GNI, resources, need to be known at build time. And typically, they are resolved at runtime. So native image works with all those features, but it needs to be instructed at build time what exactly needs to happen in terms of reflection, serialization, resources, etc. at build time by providing native image with config files for those features. So if you want to move an existing project to native image, and if you want to evaluate which libraries work, I mean, the first thing you would add is our plugins, Maven or Gradle plugin, and just try to build your application. But if you want to do a very quick assessment without having to do anything yourself, one thing that I would recommend is that we have this list of community-maintained libraries on our website. ready for GraalVM native image. And if you go there, this contains a very, very long list of something, maybe 200 libraries that are known to continuously integrate and test with native image. So you can just Control F your library here, and this will be the first sign that your library definitely works with native image. So if you want to take a photo or bookmark this page, this is the page. It's called Frameworks Ready for Native Image. But what about if your library doesn't work, and how do you solve those challenges? Now, this slide might be a bit scary, but just bear with me. So each bullet point here is an individual way to solve issues with libraries. You don't need all of them. This is complete solutions going from the best case scenario to a scenario that is maybe requires a bit more work from your side. So how can you use libraries in native image if they are using those dynamic features such as reflection? So the best case scenario is if your library is built in a native image-friendly way out of the box, and we see more and more of this lately, where new libraries appear and maintainers write them in a way that is easier for native image to understand. So maybe not doing that much reflection or doing a bit more predictable calls. Now, if your library is compatible out of the box, this is the best case scenario. What to do, though, if your library existed before native image came to be and became popular, and how can a library add support for native image? So later in the presentation, I'll show you an example of application using H2. And I like showing this example because in the past, you could not have easily built applications with GraalVM in H2 because your application was successfully built, but then it will fail at runtime because there is reflection going on in H2 that native image could not resolve out of the box. Now, this is not an issue anymore because now H2 ships configuration for native image within the library itself. So if you happen to be a library maintainer, or if you know a library maintainer that you would like to make compatible with GraalVM, the best thing they can do is add support for native image within the library itself. And the way this is implemented is in the library source code under this known directory, meta-inf native image, you can add configuration files for native image in the format of JSON files. And those will instruct native image that, for example, in this class, the reflection of this type will occur. So please discover this as you are building application and include this, and then application will just run. So from the library perspective, the best thing they can do is include config for native image within the library itself. Now, we understand that for some libraries, it will take more time to do this, and you would think that it would be great if there existed something kind of similar to Maven Central, where you can pull from configuration for your libraries from some centralized place. And indeed, we saw the same thing, and we have now this repo on GitHub called GraalVM Reachability Metadata Repository, where we have, again, a long list of libraries for which community maintains configuration files. So let's say I want to use, I don't know, Netty or some kind of database driver, and it's not compatible with native image yet, but it is present in this repo on GitHub. So what will happen if I'm using our native build tools, Maven and Gradle plugins, they will go to the centralized repo and pull this config for me without even me realizing, and then things will just work because they can pull this config and make dynamic features in the library work. Now, this is the happy path, but also if you're starting a new application, I hope that you will stay within those first 3 bullet points. You would never need to configure anything yourself manually. But what to do if that's not the case? So let's say maybe you have some internal library at a company, you need to use that library, and it's not compatible with native image, and it's obviously not available on GitHub because it's your internal library. What to do in that case? Now, the next best case scenario is if you are using a framework that is friendly towards native image. So that would be all major Java frameworks such as Spring Boot, Macronaut, Quarkus, Halidon. And they are on a version of a framework that is friendly towards native image. So for example, for Spring Boot, this will be starting with 3.0. In that case, a framework can help you generate those hints, those configuration files for native image programmatically from your application. Let's take a look at an example. So for this, I have my native Spring Boot app, not test main, here Java, and I have a bunch of things here. Let's take a look. So I have this reflection controller that exposes an endpoint, and let's see we want to retrieve this message field from the message class, so the one over here. But as you can tell, we are doing so in a maybe slightly less obvious way. And this is done specifically to try and confuse and outsmart native image, because if this was just class for name or a more reasonable reflection call, native image could detect this out of the box. So for demo purposes, we are doing this in a slightly less obvious way. And the way to make this kind of call visible to native image, because I'm on a version of a Spring Boot that supports native image out of the box, they offer me those nice annotations from the framework itself. For example, here I'm using register reflection for binding. And this will help me produce config files for native image. I just need to annotate the place where this reflection calls occurs and instruct it where exactly it needs to be available. So in my case, it needs to be present in the message.class field, class in the message field, and it will generate those hints files in the format of JSON for me. Now, this is one way to do it. Another way, which I maybe like a bit more, is let's say we want to use this resource and read it at runtime. And for that, we are implementing this runtime hints registrar API from Spring Boot, where we can say, I want to generate hint files for resources, and namely this message XML resource. So this is a centralized place of generating hints for native image. And the reason why I like this method more is because it's more flexible and more centralized. So here, I'm doing hints resources. But in a similar fashion, I can do hints reflection, hints JNI. And this will be one central place where I can generate all the hints programmatically from the framework itself. Now, this was for generating hints from the framework. Two last bullet points quickly. So let's say you are on the older version of a framework, or maybe a framework that doesn't support native image, so you cannot use any hints from the framework itself. What to do in that case? Are you out of luck? Not exactly, because we have one more tool in native image to help you there, and it's called the tracing agent. So when you get GraalVM and you get native image, it has this agent included inside, which can observe your application behavior on the JVM, and it will output those configuration files for you. So the way this works is you will run your application on the JVM with the agent attached to it, and it will look at all those calls in terms of reflections, serialization, resources, etc., and it will produce those files for you. Now, those files might be bigger because it will produce files for everything, not just for things that are missing. But this is a nice semi-automatic way to produce configuration for native image. Now, the last case that I hope you will never have to get to is you can also write those files manually. Maybe you know that you have one small call. You know exactly where it occurs, so you can always write those files manually. But this is, I hope, the case that you will never have to get into. I hope that it will always stay somewhere within those first 3 bullet points. Now, this was maybe a bit scary and maybe a bit less exciting, but if you will use libraries, this will hopefully be your hint how to make libraries work with native image. Now, let's talk about performance. So I work on a compiler in a compiler team, and obviously we care about performance a lot. So for this, I want to compare IoT and JIT. And if you were to compare IoT compilation and JIT compilation, so do you think JIT will always be faster than IoT? Can you raise your hands? Okay, very skeptical people. Okay, so I guess the rest thinks that IoT will always be faster than JIT? Okay, indifferent. Let's see. It's a fun question to ask, especially in different language communities, because I would say in the Java community, it's a common kind of perception that JIT will always be faster than IoT because the JVM looks at your application, profiles, adapts over the time, etc. And some time ago, I was back in my hometown and giving a guest lecture to students who mostly studied C at that point. So when I asked them, do you think IoT will be faster on JIT? They were like, IoT, obviously, JIT is so slow. So this is always fun to ask. But let's see this in action. So for that, I want to show you yet another demo. Let's move this higher up, and let's clean this. And let's go to a dictionary directory, the one over here. Before we do, I will just for fun show you what is the actual app, target, dictionary. No, target, what's the name? Demo, I guess. Demo. OK, it started. It's a slightly larger application, so it started in 159 milliseconds, and it's running on 8080, localhost 8080 translations. Can someone tell me what is this language? Andres, you do not answer. Any guesses? OK, this is Swiss German. It's a very fun language. If you also speak High German, I encourage you to look into Swiss German. It's very fun. I'm sure you would love it. But this application will be our benchmark for performance. So let's go ahead and let's benchmark it. And our benchmarking setup will be the following. So we have our we will use for benchmarking this tool called Hey, and we will send 500,000 requests to our application, so 500,000. And we will run it on the JVM and then on native image, and we will compare the results. And we will also wait 5 seconds for the JVM to actually properly start and be ready to accept our requests. An application will run with the same memory settings. So let's run this. Let me kill this, and let me trigger my script, bench JIT. So this will run on JIT and C2, which is your standard JVM JIT compiler in, let's say, OpenJDK. We have started, and now we will run our application and see how fast it can process those 500,000 requests. OK, we are done. You might be looking at latency numbers, but honestly, I always prefer to look at peak throughput. So our peak throughput for the JVM version is 51.7K requests per second. So let's get ourselves another tab, and let's run it on native image, bench native. So now it will run in the exact same setup. It will also have to wait 5 seconds because we were waiting for the JVM, and we want to have the exact same setup for native image. But honestly, we will see in the bit that it didn't need those 5 seconds. It was idle, ready to accept our requests. So who thinks this will be faster than the JVM? Well, you know that I work on GraalVM, so I could have applied some tricks to kind of make it look faster, right? But let's see. So this was 51.7K. This is 44. Now, I would say it's in a similar ballpark. The JVM is so good at peak throughput. It's very hard to beat the JVM at its own game. But let's see if we can nevertheless make it happen. So let's make one more run, bench native optimized. So this will apply a few more optimizations to squeeze more performance out of native image. And it's a number of things. So it's using G1GC for better throughput. It's using MARC native instructing native image to specialize the build for the specific hardware features of the machine where it's building. And it's also using PGO, Profile Guided Optimizations, which is an optimization where you will build an instrumented version of your binary, run it with a relevant workload, collect profiles, and then feed those profiles into native image. So something that the JVM normally does at runtime, where it looks at your application and sees which part of it are hot, where it makes sense to invest compilation efforts. Native image can do the same in the native mode. And some might say that native image also does just a different kind of profiling from the JVM, because JVM profiles live at runtime, which you would think will always be better. But native image has a better, kind of more complete view of your application, because this is happening ahead of time on the closed world, so nothing unknown can occur at runtime. So it's a different format of profiling, but I would say equally good. Let's compare those. So we were at 51.7K. Here we were at 44K, and the last optimized version is at 58K. Now, here, obviously, I need to make a big disclaimer that this is by no means scientific benchmarking. This is quick and dirty benchmarking for the sake of conference presentation. But hopefully, it gets the point across that if you apply all the necessary optimizations and you take time to do it, you can get a very good peak throughput from native image. It is not some unique feature of the JVM. You can accomplish the same on native image as well. One more part of this benchmark, though, was that we were also running our application with a tool called PS Record, and we were measuring the resources consumption of our application. So let's see what we got here. Dictionary, this is us. And let's compare. So this is JIT, this is native, and this is native optimized. No, we cannot compare like this. Let's do side by side. Native and native optimized. Now, what are we looking at here? So this is produced by PS Record, and this was observing all of our benchmarks in terms of CPU usage and memory consumption. And the way to read this is that the vertical red lines, that is CPU usage, and the horizontal blue line, that is memory usage. So what we see here, a number of observations. You remember in the beginning, we were waiting about 5 seconds for the JVM to start. So indeed, we see that there was some kind of overhead work happening in the beginning, such as loading the JVM, loading classes, taking a look at the classes, etc. Native image was just, ready to accept requests. Now, in terms of CPU usage, the JVM goes even a bit through the roof, I would say, while native image remains lower in both setups. And then in terms of memory usage, the JVM is quite high. And then native image out of the box memory is, I would say, on average 2x smaller than the JVM. And then the version with full optimization is slightly higher, but still lower than the JVM. So from my observations, this difference between memory consumption of native image out of the box and in the optimized version, it primarily comes from G1GC. So G1GC gives you better peak throughput, gives you better latency, but at the cost of memory. And in general, I think it's a fair kind of trade-off that if you want to have more peak throughput, you need to give some resources, some memory as a trade-off. So those are the optimizations that you can do with native image. Let's see. Yeah, so those are the optimizations that I mentioned. If you want to have peak throughput on native image, this is one slide that you need to maybe take from this presentation. So profile-guided optimizations, if you want to optimize really for peak throughput. Now, it requires an extra step. So you need to do an instrumented build. You need to collect profiles, and then you need to build again. And we realize that it's not always that our users will have the possibility to do this two-step process. So if you cannot do it, or maybe you don't care about performance that much, the next best thing we can do if you don't give us any profiles is you would think that it sounds like a good task for ML to predict the profiles of your application, and indeed it is. A native image contains a tiny little ML model that if you don't give us any profiles, it will look at your application and it will try to predict which parts of your application will be hot and invest compilation efforts there. Now, this will not be as precise as your actual collected profiles during the run, but this will give you maybe 5, 7, 8% performance improvement over not having any profiles in the first place. And as I mentioned, G1GC for better peak throughput or better latency, and you can use the flag mArch native to specialize your build for a particular machine where you're planning to run your application. So all those things together will give you performance at least on par with the JVM. Now, this is my backup. Now, best practices. If you want to move your application to native image, what are the things you want to do? I mentioned compact packaging, and especially I think this could be interesting for you if you want to do cloud deployments. So here we are looking at a way to package your application and really reduce the container image size. The blue lines, that is still on the JVM, and the orange ones, that is already in the native image world. And you can see how you can take your container image size from 400 megs to just 18 with GraalVM and native image. And in terms of specific deployment and kind of linking options, there are multiple ways of how you can build native image. Long story short, you can build it in a way that is fully dynamic. So some of the native libraries that native image will use will still be provided from the underlying operating system. You can build what we call mostly static native image, where the operating system would need to provide an implementation of libc. Or you can do a fully static native image where it's fully linked, fully self-contained, and then you can deploy it on something like from scratch container and really have this fully functional, fully self-contained container image with your native application. In terms of building applications, so I mentioned that native image produces native executables that are specific to a platform because we need some JDK classes that are specific to a platform. So out of the box, we cannot do cross-platform compilation. I cannot build on my MacBook, let's say for Linux, out of the box. But there are ways around it. One is obviously you can do container deployments. Another one is you can do things like CI/CD systems. I'm personally a big fan of GitHub Actions. I have all my projects on GitHub set up to use GitHub Actions. So there you can easily build and test your projects and even produce executables for every platform that you might need, either for yourself or let's say to distribute to your users. Now, if you are using build packs, there is also a specific build pack for native image to make your container deployments even easier. And in general recommendations, if you maybe want to take one slide, how to migrate your applications to native image and want to do when you migrate it, this will be the slide. So the first step to migrate existing applications is to add other native build tools, other Maven and Gradle plugins, or maybe you are on a version of a framework that includes those native build tools out of the box. To build and deploy, in general, I recommend that you build your application on the JVM. You don't need to recompile to native every 5 minutes or as you're introducing changes to your business logic. You mostly need to recompile to native if you add a new dependency, or if you touch things that are not sensitive to native image, so reflection, serialization, proxies, etc., or maybe once a day on your CI/CD, but you don't need to recompile all the time. You can just stay in the JVM world and then compile to native when you actually need it, or closer to your deployment. Now, in terms of monitoring, you have many options available to you. Most of the standard JVM monitoring features work. So JVM stat, JFR, JMX, Micrometer, you can just observe your applications with those. More demos. Let me see how you're doing on time. Andres, can you help me? Do I have 10 minutes or? No one knows. Yes. 10 minutes, right? OK, let me see if I can show you one more demo. And I want to show you a very fun one. Let me see if I can switch to another cloud instance. Let's see. OK, so this is my LLM instance. And I want to show you a very fun way to run LLMs with GraalVM. I promise this is something you probably haven't seen yet. For that, let me go here and Llama 3. So this is a great project written by my awesome colleague, Alfonso. And this is LLM inference implemented in pure Java. So the project itself is just one Java file, this llama3.java, which is not even that big. This is maybe 2-point-something K lines of code, which is comparable with some standard classes in the JDK library. And this is a complete LLM inference engine. So if you want to have your little AI chatbot available for you on your own machine locally, fully without internet, without anything, without any API keys, this will be it. You just need to get this file and the actual models file from things, let's say, like Hugging Face, and then you can have it available to you. So you only need a model, and then the entire logic of interacting with that model is implemented here in this llama3.java file. So it does everything: interaction with the model, processing your input, processing the output, the strategy of how this output should be generated. It's all in this Java file. There is no Python, no C, no dependencies, nothing. I think this is pretty impressive. And it's also a great project to showcase the latest Java features. So this is using FFM to interact with the native code, and also the vector API to make it faster. And then, obviously, GraalVM makes it even faster and more awesome with native image. So let's see how you can run it. And I already have it compiled here. And this is my llama.3 native executable. It's only 22 megabytes. Granted, the models file, it's a bit larger, but my actual inference engine is just this little file. So let's run it. And I want to do this one, I think. So the startup, you can see here, is an impressive 0 milliseconds, which I would say sounds a bit fantastic and even hard to believe. And this is because of native image and how it compiles the application ahead of time. You can include some metadata of your model in the image itself. So this application is specialized to work with this model to reduce any startup whatsoever. It's specialized towards this Llama 3.2 1 billion parameters model that I have on this machine. So let's say, I don't know, hello. What can you do? Oh, I cannot type. And as you can see, it responds pretty fast, so probably faster than I can read. And the speed where it will eventually stop responding will be something like 30 tokens per second, which is way faster than human reading speed. So this is a very fun project that I think, as I said, showcases latest Java APIs. But also it shows how GraalVM can make it even faster, because this startup times of literally 0 milliseconds, this is pretty insane. And also, I think this is a nice, convenient way. Let's say if you are traveling and you don't have internet connection, but you want to have a little LLM assistant, this could be something you can do. Or also, the code is heavily commented, so if you want to see how you can implement something like that yourself, you can also use it as your inspiration for that. So hopefully this was fun, and if you want to give it a try, its name is llama.3.java, and the whole source code is available on GitHub if you want to give it a try. Now let's see. Very quickly about reduced attack surface. So I mentioned that native image reduces the attack surface because it eliminates the code that you are not actually using, but then things like serialization or reflection only can happen if you allow it. And one more security feature is that native image includes support for SBOM. So if you want to see what's inside your native executable, native image can help you scan your application and see what is inside. And with that, what is next? So the latest release of GraalVM is GraalVM for JDK 23, but we already have early access builds for JDK 24. So if you want, you can help us try and test our upcoming release, GraalVM for JDK 24. And if you're using Kafka, there is this very cool new Docker image that lets you compile Kafka brokers as native images, and they say a lot about how they see a lot of performance benefits and resources usage benefits from compiling brokers to native image with GraalVM. And I will skip this because I'm afraid that we will run out of time. So to summarize why native image, I hope I convinced you by now at least to try native image, because it will give you a chance to start your Java applications much faster, reduce your resources usage, and have very predictable performance, in addition to things like additional security, compact packaging, and support from all those cloud frameworks and vendors. So to try GraalVM, you can go to our website. That's where we have our docs and our demos and everything you might need, our downloads. And I encourage you to use SDKman to install GraalVM. This might be the easiest way to install and manage new JDK distributions. And if you want to ask me any questions, here's my Twitter. I should probably replace it with Blue Sky by now. And if you want to find demos, they are over there. I will also be here if you want to ask any questions, or if you want to have some GraalVM stickers, I will be available here. With that, thank you very much, obrigada, and enjoy the conference.